everyone, it's Kimberly Sepagunan. I am from Batangas State University. Currently, I am a third year mechatronics engineering student and I will be creating a video in compliance with our final project in CAD CNC CAM MEXE 408. So we were instructed to create a comprehensive self-video demonstrating their CAD modeling process. The video should include clear explanations, label annotations, and a coherent narration, providing insight into the thought process and techniques employed during the model. So for those people that don't know what is CAD, so I will briefly inform you what is CAD. So CAD is a computer-aided design. Modeling is a critical tool in design and manufacturing process. It allows designers to create and visualize complex 3D models of products. The advantages of CAD modeling include efficiency, because CAD software allows a designer to create models quickly and accurately, reducing the need for manual drawings and calculations. Second is collaboration, because CAD software allows engineers, designers, and other stakeholders to collaborate on projects from different locations, cutting down on travel and communication time. And third, CAD is also errors reduction. By creating and testing 3D models digitally, engineers can catch errors in design and manufacturing before they are made physically, resulting in cost saving and improved product quality. Fourth is flexibility, because CAD software allows designers to make the changes to models quickly and easily without having to start from scratch. This can be particularly useful in situations where products must be customized for specific customers. And the last is sustainability. By reducing needs for physical prototypes and samples, CAD modeling can help reduce waste and minimize the environmental impact of design and manufacturing process. So to summarize everything, CAD modeling is a powerful tool that can save time, money, and resources in the design and manufacturing process. With the right software and trained team, its advantage can be fully realized. So for today's video, I will be showing you how to design a door hinge assembly. So this will be our product, and this is the length and width of everything. So here it is stated the item number, the part number, the description, and quantity. For those people that do not know what assembly is, we will going to create various part and we were going to assemble them by using the features of the Solidworks. So let's do the activity. So let's get started. Let's view again our basis. So here we will create this first part 1. So it says in description it is 6 by 30 millimeter. So this is 60 millimeter and the height is 30 millimeter. So we will go to Solidworks, go to top plane, normal to top plane, and use the corner rectangle. So use this to easily create the rectangles, and you will smart dimension it into 30 by 60 stated on our basis. Next, we will be creating another here, a U. So just create a U first and click escape. After clicking escape, you should smart dimension it to 10 based on our basis. The width of this is 10 and the width of this is 10 also. So to clean this, click trim entities and trim this line. So there you go, we created it. Then next is if we will look on the basis, it is fillet by 3. So we will going to use this sketch fillet, set it to the fillet parameters into 3, and just click this and this. Then do it from the other parts. Then select OK. After selecting OK, you see that our basis of part 1 is already created. So after sketching it, let's use in the sheet metal the base and flange tab. So click this with 2 millimeter thickness. So click OK, and there you go. Instead of using extrude in features, we use the base and flange tab on sheet metal. It is because we need to use this feature hem, and this is only applicable on a sheet metal part. So next, if we look back to our basis, there is a curl here, this part. So it is 8. The diameter of that is 8. So we will be using this feature hem. So it is stated here that we will be picking a side to curl it up. So click here and click here. So you will click bend outside and roll. So you can actually use offset to change direction, and there are different types and sizes, and the bending options inside and outside. So here our degree is 285 with 2 millimeter. Now after clicking that, we can now click OK if you followed this. And here we go. We created our part 1. So going back to our basis. So this is our basis. And we have a circle here where is the screw will be placed. So we will going to normal to this face of our part 1 and draw a circle. Then you will going to find this line and this. So based on our basis, this is 10 millimeter. This is 10 millimeter also. And let's go back to our basis again. So it is said here that the center of the hole is 5 millimeter from the outside line into its center. So we will going to smart dimension it from here to here should be 5, and here and to here is 5. Here is 4. So now that we already put the circle, so the circle size is set to be R3 all. So go to smart dimension again and just put it to 3. After that, we will going to use the features extruded cut. Click here, then click here, and click OK. So before we click OK, we have different options here. Blind, through all, up to next, up to vertex, up to surface, up to body. It has different function, but here we can use blind and through all. Let's use through all. So through all is from here, this face, up to the bottom. That's the meaning of through. So click OK, and now we have a hole for our roof. So this is our part 1 in our assembly. Go to here, click save, and let's name it part 1. Now that we saved it, we will go to the next part. So based on our basis, it is the part 2. So after saving this model, let's make a new part. So click new and click part and OK. So after creating this new sheet in Solidworks, let's sketch on the top plane. We will use again a corner rectangle. Let's draw from the origin and expand it. And use smart dimension. So based on our basis here, it is 40 by 29 millimeter. So this will be 40 by 29. Now we size it based on our basis. Let's use again the sheet metal section, the base flange tab, and it is right that it is 2 millimeter. Now click OK. So after we use the base and flange tab, let's go to corners. So select corners and break corner and corner trim. Now select this break type and set it to 3 millimeter. So why did we use a break corner instead of a fillet? So we use a break corner since we will going to fillet a sheet metal. So here, click all the corners. Then let's look at the top. So this break corners works as well as the same as the fillet features. So here, this is the fillet feature that works like this. But since we were using sheet metal, we should use the break corner feature. So click OK. And there you go. We rounded the corners of our corner rectangle. So again, let's go to edit feature and click here and click here and click here. Click delete. Click here to delete it that fast. So now that we deleted it, let's click OK again. So that is how you do not repeat again the model and easily delete the feature. So next, let's look at our basis again. So in our basis, here we have this, which is 60 millimeters. So let's go to our model, click hem again, and click this part. And click reverse direction. Now next, let's go to edit hem width. Click edit hem width to edit the width of our hem. So let's just click it here, adjust it here, and adjust it here. So let's smart dimension it from here to here to 1 millimeter. And smart dimension this to its length, which is 38. 38, not 39. Oh, 39. 38. So click finish. And there you go. We added the ham length. So now let's go to sketch here on this face. Click normal 2 and create a corner rectangle. Put on this side and click check. Now go to sheet metal. Click extrude cut. So it is through all, but we can use blind and link the thickness. And there you go. It will cut the highlighted part based on the thickness of this. So click OK. And you can see that it cutted it out. But it is the same as the extrude cut in the features, but since we use sheet metal again, we will use this extrude cut under the sheet metal tab. Part 2, we will be creating this three circle. So with radius of 3, first as we go back to our sketch and normal to this, go to sketch and click this sketch, create a circle, 3 circle here, smart dimension, so this is from here to here is 5, and from here to here is 5 also, same here. So here we can use control, click the center and here, and click horizontal to make them equally in their places. So to check it, let's smart dimension from here to here. It should be 5. And from here to here, it should be 5. So let's X that. So base here that the center circle is 20 away from this side, 20 millimeter away, and 7 away from the bottom part. So smart dimension, click this and click here and put 7, and again click on the center of the circle, click on this side and click 20. So there you go. Now we will going to fix the circle on its given radius. So this 3, 3, 3. Click OK. Now that we're done here, now that we draw it, go to features, click extrude cut and click OK. So here we will be using blind and link to the thickness. So there you go. We have a holes for our screw, this part. So before we move on to the next part, let's go to features. Click fillet on this drop down arrow click chamfer. Then we will adjust it to 1 millimeter and click on the side. Then click OK. There you go. We chamfered our screws. So now let's click again new part and OK. Then let's sketch on top plane. Then go at our basis. So we will be creating this part. So let's go to Solidworks, to sketch and circle. Let's draw circle here first. Circle, big circle outside and small circle inside. So this is our washer. Go to smart dimension. This size is 8 and the size of the inner circle is 4. Select OK. And now go to features. Select extrude boss or base. Select this part, not this part, but the outer part. And click this drop down. This is 1 millimeter. Then click OK. So this is our part 3, our washer. So save it again, save us to part 3. Part 3 washer. Our part 4, which is the pin. So this is the basis for our pin. It has 60 millimeter on height and 4 millimeter on the base and 8 millimeter on the top. So we will be using extrude boss, swap boss and base rather. I will explain it to you why later. So let's draw the half of our pin. Since it is half, we will put this in 4 and this in 2, this in 3, and this measurement is 60 millimeter. So now that we were done on the pin height dimensions, let's go to revolve boss and base. So the reason we will be using revolve boss and base instead of extrude boss and base is because this is much easier than to create this manually. You will just going to select the axis, which is this line, and there you go, you have the pin. Now since we were done, we will be going to sketch features rather and click fillet, and the measurement of our fillet is 1. Then click this side, not that side, or click this side and click the bottom part. Then click OK. Now our pin is done. Let's go now to our assembly to assemble all the parts. But first, let's save this first. So go to save as. Let's rename as part 4 pin. Save. Then go to new and click assembly. Then click OK. Now here in assembly, our purpose is to assemble the parts that we did. So let's click OK and go to insert components. So insert components is to add an existing part or sub-assembly to the assembly. So we have here our part 1. And you can see that it is built already. So let's redo it because we need to put it on the axis. So first click the view and view origins, then click again our part 1. Now you're going to align it on the axis. And now that you aligned it, now let's proceed to insert the part 2 of our hinge. And now that we inserted it here, let's go to mate. So mate is, it creates a geometric relationships between components to define the allowable directions of linear or rotational motion of the components. So click mate, click this side of the hinge or hem, then click this hem in part 2. Now there you go. It is mated perfectly. Then click check. Now you can just like move it around, but we will not going to move it around because we will going to use a washer to fully close this. So click undo, then let's mate it again. So mate, mate, and there you go. We mated our parts. Then let's just, no, let's put it concentric. Then check, then let's move it like here. Then click OK. After we click it OK, now let's go to insert components. Now we will going to use our part 4, which is the pin that we just created. So to mate this, click mate, click this part of the hem of part 1 and click this part of the pin. And now we're going to add and finish the mate here. To put the pin inside, go again to mate, click this face of our pin and click this face of our hem of part 1. There you go, it is fitted perfectly. Then click OK. Now that we assembled it, the pin, now our last part is the part 3, which is the washer. So again, go to insert components, click part 3, the washer, and click mate. So first, let's click this part of our pin, then click this part of our washer. Now you can see that part is perfectly aligned inside. So we're going to add to finish mate and move it here so that we can see the space because we need this face to mate it here. So click this and click this and there you go. It is mated perfectly. So click check. Wait, we're going to undo. So click this and this instead. I'm sorry guys. So click add and finish mate and there you go. We added the washer. So this is the final product of our project, the door hinge, assembled part by part. So hi guys! If you reached the end of the video, I thank you for listening to my video and I hope you learned a lot of lesson. And it means that you completed the door hinge tutorial. So thank you and I wish you luck for your further advancement on CAD, CNC design.